It is my distinct pleasure and privilege to introduce our next speaker. Dr. Jonathan Lundgren is a very good friend of mine, and we've become closer and closer as we continue to do some things together. And I look forward to continuing to work with him much more in the future. But Jonathan is an agroecologist. He has a PhD in entomology, and if you don't know what that is, it's a study of bugs, okay? But he has a similar life story to me in that he's started his career as an academic. He was with the USDA ARS as a research scientist for a number of years and actually won a number of awards, including a presidential award for science and engineering that was presented to him at the White House. So as a researcher, he has an impeccable reputation and career. He is a very prolific author, but Jonathan made the distinct decision to leave the formality of academia. I'll let him tell you a lot more about that and why. And then to form his own research company and foundation called Ecdysis, and his own practicing farm called Blue Dasher Farms, which I had the distinct privilege of being on a couple of months ago. But Jonathan is one of the very best people I know to be able to relate to you how all of this insect life fits in to the rest of the ecosystem, and particularly to agriculture, and why instead of trying to spray out and kill all of these insects, we really do need them. So as I have Jonathan come up here, I want to tell this quick story about Jonathan. So Ray, you're not the only one, okay? So, as Jonathan started Blue Dasher Farms, he came to me one day and he said, "Alan, I got to have a tractor, all right?" And so he said, "Please help me find a tractor." So he started looking around, and finally another friend of his actually found him one that he bought. But as soon as he got it home, he discovered the darn thing wouldn't run. It wouldn't crank, nothing. It actually had a cracked engine block. So he had already spent all this money, $5,000 on this tractor, and he didn't know what to do with it. And he got the bright idea that he would hold a raffle for this tractor. So he went around South Dakota selling raffle tickets for $100 a piece for a tractor. Win a tractor for $100 a piece. And do you know he sold 10,000 of those raffle tickets, okay, at $100 a piece. And I looked, he told me about his success at selling these raffle tickets, and I said, "Jonathan, the tractor doesn't work. What are you going to do for the fella that wins it?" And he said, "Oh, no problem. I'm just going to refund his money." So Jonathan Lundgren.
All right. It's downhill from here, folks. It's downhill from here. All right. Yes, thank you, Alan. It's so good to be here, you guys. I've heard so much about this meeting and all of you. So it's an honor to be here and talking about some of our science and things along those lines. So I'm an entomologist. Things that I like to study are risk assessments. So I like to try and understand the ecological risk that is posed by our management decisions to the environment. And then I also like to try to develop new systems where we don't need a lot of pesticides. And I'm going to talk about that more today, I think. Tomorrow we can talk about more the science, how it's manipulated, whistleblowing, all of that good stuff. But for today, let's focus on solutions, okay? Insects. Right there, okay. When I tell people that I am an entomologist, oftentimes they say, "Oh, entomology, yeah, the only good bug is a dead bug," right? I hate those things. They get in my house and they're so awful, right? And entomologists, you know, they understand this. There's actually, we've identified something like 5,000 pest insects around the world, you know. These things are awful. They have literally changed human history, insects have. They bite our children in the night, right? They come in and they nibble on our kids. Oh my God, that's a pest. They eat the food right out of our cupboards. They literally, insects have killed more soldiers than bullets or bombs have through disease transmission. 5,000 pests, 5,000 pest species out there. We got to kill these things, right? We got to buy a jug and we got to spray the hell out of them, right? Humans over bugs. That is not what we do. That is not who we are. Because insects, when we have this mentality towards so many of the things in Mother Nature, right? But when we have a pest-centric mentality toward insects or other forms of biodiversity that are out there, we forget that that's such a small fragment of the pie. Just a very, very sliver. For every one species that's out there, there's actually 1,700 species of insects that we can't live without, right? That are providing us services that we can put a value on that humans simply would not be here if it was not for all of this other diversity. So what are some of these services that insects provide? Well, if I had to put it in a nutshell, I would say that they're the basis of complex food webs, okay? Of biological networks. That's what insects, that's the services that they provide. But if we want to get into the nitty-gritty, entomologists value insects at about $63 billion per year that they are saving society in the US alone. $63 billion per year. That's the number we've put on it. That's an underestimate by far. What services go into that? Well, does anybody like to hunt or fish or bird watch? Any bird watchers? Yes? Okay. If you do, think a bug. They are the basis that supports much of the wildlife that we appreciate for our recreation. Okay? I hate to say it. We've started to feed people at these conferences insects, and they love it, right? Cricket cookies, right? Cricket cookies. Chocolate chirp cookies. We had those down in insects. Okay, and I'm saying this at a livestock meeting. Insects convert feed into protein at a rate that kicks the ass of any livestock that we're currently raising right now. So, I mean, and really Western cultures are the only ones that don't rely on insects as a major source of protein in their diet, right? If you've ever eaten a lobster or crab legs, hate to say it, folks, but that's a giant insect, all right? And the rest of them are really tasty too. I just got back from China and I had some locusts that were delicious. All right. Insects regulate herbivores. Insects are nature's insecticides. We can use these, right? Insects are nature's insecticides, right? They're nature's insecticides. They're killing a lot of the herbivores that we have that we designate as pests. Insects, when they eat the seeds of weeds, when they eat, the green parts, the roots, insects shape when and where you have a weed problem on your property, okay? We can use these. We can use these as tools to reduce the amount of inputs that we need. Anybody like fruits and vegetables? Yes, if you do, thank a bug. Because without pollination services, we would not have most of the foods that we enjoy. And the bee, so imagine losing 50% of your crop or your herd on an annual basis. 50%. That's what we're asking of the beekeepers right now. We're losing 50% of our honeybee hives on an annual basis. And when the EPA found out, they said, well, they can make more, right? Bees reproduce. They can just split those hives. You know what? You lost half of your herd this year, but good thing, cows reproduce, they have babies, so no problem, right? No problem. It's real simple, folks. No bees, no plants, no plants, no people. Yep. And finally, insects are things like dung beetles, things like decomposers are an essential part of soil biology. We often hear soil biology, that means microbes, right? Yes, they're fine, but they don't have enough legs. They're not cool enough. You can't see them, right? Insects are an inherent aspect of soil biology that we often ignore, and that science is just now, and our lab is one of the few in the world that are working on this, where we're trying to value what the insect's contributions to soil health really are, okay? So, all of this is great. There's hundreds, like millions and millions of species that are out there. All of this is great, right? We often hear, okay, the bees are in decline. I already said that. This is not a bee problem that we're facing right now. This is a biodiversity problem that we're facing. And the bees may be the canary in the coal mine. They may be the poster child that we slap up there to motivate people to care. But let's not lose sight of the fact that the bees are just the tip of the iceberg. We're losing entire habitats, wetlands. I'm from South Dakota, eastern South Dakota. We have the prairie pothole region out there. We're losing wetlands at an alarming rate. Entire grasslands. Where'd the prairie go? We're down to 1%, something like that, maybe a fraction of that. Entire insect communities are in decline. We're losing butterflies, birds, bats, bees. This is the Holocene extinction event, folks. And it's worse than anything that planet Earth has ever experienced before. This is worse than the dinosaurs. We are losing species at a tremendous rate. Meanwhile, agroecosystems have become progressively more simplified, right? And they are now currently the largest biome on planet Earth. 34% of the terrestrial land surface of our planet is devoted to food production. That doesn't mean that again, Lundgren hates farmers. Did you hear that guy? He hates farmers. No. 34% of the terrestrial land surface is devoted to food production. That gives us a tremendous tool for combating planetary scale problems, okay? Through our management decisions, we can use our food production system not only to produce healthy food for society, but to also offset climate change, pollution, invasive species, so many of the issues, critical issues that our society and our planet is facing right now, okay? So that gives me a sense of hope. I'm not going to talk about that. What does this simplification of agroecosystems look like? This is what it looks like from space. This is where I live, right there. Right there. Oh, that little jiggling dot. I'm not nervous, it's just far away. Okay, so what is blue is corn, green is soybeans, and red is cotton. All of this is genetically modified to resist, well, the corn and the cotton are almost entirely genetically modified to reduce, with insecticides, to reduce pests, BT varieties. Almost all of this acreage is now sprayed with glyphosate, Roundup, many times a year oftentimes. It's all maintained with chemical fertilizers, right? So when we say to the beekeepers, it says on the side of a jug, hey, before you spray this, tell your beekeepers to move their hives. And the beekeeper's like, where the hell do I move it? Right? Pesticides are an addiction. Pesticides are an addiction. Let's call it out, folks. Let's call it out. Let's be real frank here. The more you use, the more you need. That's an addiction. Who wins in an addiction scenario? It's not the addict, is it? It's the guy pushing the drugs. Who's winning in farming right now? Is it the farmers? There's a lot of money being made in farming right now, right? But it's not by the farmers. Okay? The only way to maintain a degraded ecosystem is with more chemical inputs. But, and I'm not saying ban all pesticides. That's not what I'm getting up here and telling you. What I'm telling you is I'm trying to be a voice, maybe one of the few that you'll hear, that says, listen, there's unintended consequences. We are scientifically incapable of predicting the risk of what is in that jug to the environment. I've studied risk assessment for 20 years. It is impossible to predict how this is going to affect the environment and beneficial species and you. There's consequences to this use. We give, as entomologists, we love to give advice. We get up on a stage and stand behind a podium and say, you're going to have this pest problem, this pest problem, this pest problem. What you do is you buy this jug and this jug and this jug, and then you put it out there. This is how much you put out there, and this is when you put it out there, and this is, and then you'll make money, right? Then you'll make money. But I started to look in my own state, South Dakota, and we started to look at the data, and I'm like, we've never actually had a concerted survey to find out when and where pests were actually a problem in South Dakota. And so we're giving advice based on impressions, and that's not always good, right? That's not always good. 53 farms. We decided to try to change this. We went out to 53 corn farms, okay, in eastern South Dakota. And these are the counties that we hit. Once you start getting west of here, it's mostly rangelands. It gets to be very dry. These 53 farms spanned a continuum of conditions, but they all had to be 10 acres in size. They all had to be non-BT corn. I wanted to know what insects were out there, okay? I wanted to know which pests and which beneficials were in these cornfields. And then they had to have no insecticides. But what we quickly came to the realization was that that was not feasible because so many people, without even knowing oftentimes, are buying insecticidal seed treatments, neonicotinoids. Have you heard of these before? This is one of the most critical issues that that our society is facing in agriculture right now. One corn seed has enough insecticide, neonicotinoid insecticide, to kill 360,000 bees. One seed. We are currently planting these neonics on 13% of the terrestrial land surface of our country. And they're almost entirely unnecessary. The science is clear that they are not helping farmers. So we had to decide, it got real quiet. We had to decide to include minimal insecticide use, the low rate. And then we sampled later in the season, hoping that most of that was out by then. What did we find? We often think of cornfields as a desert. They are not. We found 107 different quote-unquote insect species. These are anything with like more than 4 legs or less than 2 legs, okay? Just in the corn canopy. When we look in the soil, we can increase that by about 450 species, all right? And that's just in one part of one state. That's where we were finding them. Of these, 7% were primary pests. These are things like corn rootworms, European corn borers, things that farmers hate, that reduce yields. But on all 53 farms, none of them, not once, were they at economically threatening levels. Farmers were purchasing more than $100 per bag of seed. They were devoting specifically for managing pests that weren't there. That's dumb. That is a bad business decision. That does not mean John Lundgren hates insecticides and genetically modified crops. That is stupid, right? These farmers have been lied to. They've been lied to. Of these 107 insect species, 13% have some impact on corn. They're neutrals, right? They're nibblers, but we don't manage them. What is the other 80% of species? Predators. We found 150,000 predators per acre in cornfields. And that was in some of the more heavily managed cornfields. Yeah, I could go on and on about more regenerative farms. What are these things? Lady beetles, spiders, ants, lacewings, things like this. Pirate bugs, yeah, wonderful critters. 107 species. How do you get your head around that kind of diversity, right? I mean, we love to study things that are just encapsulated, right? Just very minimalist so that we can understand how they're all interacting. But this necessitates that we use a biological network approach. So we developed, to try to understand what was driving pest dynamics in cornfields, we adopted literature from, information, statistical approaches from the sociological literature. 7 degrees of separation from Kevin Bacon. Have you ever heard of that? Right, so everybody in this room knows Kevin Bacon through acquaintances of acquaintances, and they use network theory for understanding those interactions. How does information transfer through the World Wide Web? They use the same sorts of ideas that we were going to now try to apply to biological systems. So our understanding of these complex biological networks tends to come from, a very simplified system. We get a black plastic pot and we put a plant in there, and then we put a pest on there, and then we put another critter in there, and you're like, oh, this happened, right? Which is great for understanding some of the mechanisms, but it vastly ignores the complexity of the natural world. This is a network, right? Oh, what happens if we get more of these? What happens to this? This is a real network. This is a network from a real cornfield. Each dot is a species. And we drew a connection if they were numerically correlated with another species. So if this is our pest, if number 80 over here is the pest, and you decide to spray that one species out, then you find that it's connected to species, connected to species, that's connected to species, right? What drives? So the pest isn't the problem, right? What's driving the abundance of this pest is everything else in this hairball. But we're always just focused on this, on that one little component of that complex system. Okay, so each dot here is a cornfield. We've got species diversity up here, and we've got the pest abundance down here. What these graphs are telling you is that as species diversity increases in your cornfields, you do not have corn pests. As you reduce diversity, that's where you have the most abundant pests. That's what these graphs are saying. This is a cornfield with high pest abundance. It's broken. It's broken. Right? No connections anymore. Lots of species that are completely disconnected. And that teases out statistically, right? As we look at the connectivity of these networks, that is what's driving when and where you have a pest. As you look at the diversity of your cornfields, that is what drives your pests. We have now done similar analyses, not including networks because it's a crap ton of work, but looking at just diversity of the bioinventories that we're collecting. This is true of granivory in soybeans. This is true of dung beetles and fly removal and dung pat degradation rates. This is true in organic systems and predation rates. This is true in cornfields and predation rates. We've got it. This is a consistent pattern that we keep on seeing, but it requires us to change the way that we think. We can't think of just the pest anymore. We have to think of all of the hundreds of other species that are producing that pest to begin with. Biodiversity is the answer. The complexity of these interactions is what affects your pest abundance. If you have a pest on your ranch, if you have a pest in your cornfield, that is not the problem. I better buy a jug. I better put a jug out there and I better spray it out there and kill that pest, right? And then the pest becomes resurgent or something else comes along, and so you better buy another jug, right? You're not solving the problems, you're solving the symptoms. What produces pests is a lack of diversity, too much disturbance. That's what drives pest dynamics. If you really if insecticides were the answer to insect pests, we'd have kicked their asses 50, 60 years ago. Right? Why is biodiversity important? This is my son standing way too close to a raging Colombian river. Biodiversity provides services. Whenever we try to replace Mother Nature with technology, it may work for a while, but eventually Mother Nature turns around and kicks us in the crotch. Right? Right? Every time. This is not my opinion. This is demonstrated throughout human history. All right, let's get on to the rangeland stuff. This is work, one of my master's students, Jacob Pachenka, he just finished up his master's. He's getting his PhD now at Purdue. But he worked on community dynamics and maggot control in cattle dung in eastern South Dakota. And so this is just a part of some of his data. Right. Right there, guys. So there is a proportion of people in this audience that when I flashed the big old cow turd up there, they were like, yeah! Yeah! It's going to talk cow crap. You're my people. Those are my people. All right. Dung as habitat, right? We don't think of dung as habitat very often. 450 species of insects have been found in cattle dung. Okay, that's in the U.S., okay? 30,000 dung beetle species worldwide. We have about 1,500 in North America. And most of those are eating dung. They aren't all eating your cattle dung, okay? There's only a couple hundred species that are eating cattle dung in the U.S. Of these 450 species, about 1.5% of these species are pests. Okay? 1.5 species, mostly flies. That's just in the dung, okay? But yet these are the ones we really care about, right? That's the only ones we really care about. I showed you all that corn information for a reason, all right? We'll get to that. Flies and maggots, those are the pests of concern, right? How do we manage these pests? Ivermectins, right? Ivermectin and their kin. This is one of the primary ways that we've managed. In fact, they gave the guy a Nobel Prize for inventing or discovering ivermectins, right? For their human health and disease management. This is a neurotoxin, and it disrupts cell membranes, okay? That's how it works against insects. It's extremely effective, both as a nematicide and as an insecticide. And it's applied in a number of different ways, right? You guys all know this. You can pour it on, you can inject it, you can feed it, And it's applied to the majority of the cows and cattle in the U.S., okay? But there's problems with this, and those aren't on the side of the jug. 80 to 90% of the product that you put into the animal comes out in the poop, okay? And like I said before, it's extremely effective at killing insects. It lasts for up to 240 days in the cattle crap, okay? And all those turds. And it kills the other 98% of the insects that are associated with that. Right? Very effectively. What causes pests, you guys? Not enough diversity and too much disturbance. We wanted to know, farmers or ranchers that were managing their rangelands using a regenerative model, what happened to their maggots versus folks that were using things that are using practices that would be considered, conventional. Continuous grazing, Ivermectin use, yada, yada, yada. We looked at this intensively on a series of 16 ranches in eastern South Dakota over 2 years. These ranches spanned a range of different conditions and management practices, but these were defined, these were successful ranches, okay? These were defined by their best management practices as defined by the ranchers themselves, who would go down these different systems. Based on the practices that they're employed, we categorize these into regenerative and conventional ranches and then an intermediate group. The regenerative ranches had high stocking densities, they moved their animals frequently, and they completely abandoned all pesticide use in their animals. The conventional ranches had a low stocking density, they left them on there for a long time, and then they always used, at least twice a year, Ivermectins, okay? And then we surveyed the living crap out of the living crap. So we took golf cup cutters. So this is a unique way of studying insects in poop. Normally you put a trap out there and hope things come to it. We went to the poop itself. And so we took a golf cup cutter and we took a core, and then we put the steaming poo into here, and then we heated it up with this light bulb. And then as the insects warmed up, they all went down and escaped the light and the drying turds and fell into this receptacle called a Berlese funnel. This was by far the nastiest project that we've ever run in the lab. Take that poop and heat it up. But we got a lot of species this way. In fact, we collected and identified to species level, just for this part of the research, 116,000 insect species. Or not species, 116,000 specimens that we had to identify. There was only 172 species. This is actually more species than we find in soybeans, which is disturbing on many levels. Roughly 400 insects per pat. Tremendous diversity that really has not been described before. What did we find? What we see here is species richness. These are two metrics of diversity. You've got your conventional, these are continuously grazed, Ivermectin applied. You've got your regenerative farms are over here, and then you got these little weirdos in the middle. Species diversity was encouraged. Okay, you saw just by changing your management practices, you increased your species diversity in your dung pads. Maggots were significantly more abundant in the insecticide-treated animals than in the ones that don't apply insecticides. Right? That's not supposed to happen. That's not supposed to happen. These guys and gals did not just eliminate Ivermectins from their system, they replaced it with good management practices. That's what they did, all right? That's a good bit, so why would you, that's a bad business decision, right? Predators, and the more Ivermectin, I didn't show this graph, but the more Ivermectin that you found in the pat, the higher the maggot population was. It was positively correlated. Ivermectin use was encouraging maggot populations on your plot fields. It wasn't eliminating them. Predators in those pats, as Ivermectin increases, predators decrease. You find that the ratio of maggots per predator is very low. Down here, that's what you want. You want you want one predator, one maggot kind of a situation. That's how they eat things, right? Versus in the conventionals. Predator reductions are probably one of the mechanisms that's going on here. Folks, insecticides are an addiction. It's an addiction. It's not helping. It's not getting us where we need to be. The pests aren't the problem. We need to change our mentality. When you have a pest in your field, in your ranch, figure out what caused that. That is your field, your ranch telling you something. Listen. Change the system so that you don't have that pest problem. Don't react to the problem once it's already there. How do you combat pests without pesticides in ranches? Here's some thoughts. Step 1. Get off of the drugs. And it's painful. It's painful to watch. Right? Suck it out of the system. High intensity grazing. Right? But couple that with frequent movement of animals and long rest periods. Because that is how you have fostered diversity within your system. A healthy plant community is how that happens. Without a healthy plant community, that's how the energy is getting from the sun into your soil to feed everything else and support that whole system. You have to have that as the first step in this process. Well, second step, after you get off of the drugs. We've got to start thinking about integrating herds. This idea of just one species out there at one time is not getting us where we need to go. We need to diversify not just our pastures, but also the animals that we're putting on them. Okay? And the science on this, man, I have not seen a lot yet. But what this is based on is me observing ranchers that are doing it. And that's kind of where we're at on a lot of the stuff that you guys are, you guys are leading this charge right now. You guys are so far ahead of the science that we need to start we need to get the science up to snuff with what you guys are doing. It comes down to this right here, right? Why? Why are you here? Why did you come to this meeting? Why do you manage your herds differently than almost everybody else in the country? Right? Why do they manage theirs more conventionally? That question of why, is it, man, last year I had, so many pounds of beef. Yeah, right? That's why I'm here. I grow beef. That's it. That's why I'm here. That's why I do what I do. Is it? Is that why you do what you do? So I was one of the top scientists in the USDA, right? I was doing everything right. I had millions in grants, students up the yin-yang. I had, advising the government, not just the US government, Europe, Brazil, all of these places, right? Everything I was doing was right. And a lot of it was supporting the conventional system. And then I started meeting people that were doing things that I thought could be done and should be done, but the science said couldn't happen. These ranchers and farmers were diversifying their operations, eliminating a lot of their pesticide use in spite of the science. And then I started meeting beekeepers, and they were telling me, no, you know what? The pesticides are killing our bees. And the science said, no, it's not enough forage, and it's the varroa mite, and there's a new disease. It must be that's killing your bees. And so I started to listen to you guys, and I started to do the science that would support what you were doing. And it validated what you were observing on your ranches and your cropland and your bees. And then everything changed, right? And the USDA decided that was not what they wanted to be promoting. They wanted to be promoting the current system. And so they started to suppress science. And so I quit. And I quit kind of noisy. We blew the whistle on this. And we said that suppression of science is stifling the innovation of our food system. And it's making us a more brittle society than it is helping us. And we started something entirely different, right? We started something entirely different. Why? Why did we do this? It wasn't because I was angry. It was because this planet is facing some serious problems right now. We can bury our head in the sand as long as we want to, but until we have people that have the integrity to act boldly to try to change this, then we're on a really dangerous trajectory. So the status quo isn't good enough. And so we reached out to the farmers and the beekeepers and the ranchers all over the world, and we said, if you believe that regenerative model of agriculture is something that needs science and education to support, then consider donating. And people did. And we crowdfunded through an Indiegogo campaign. We crowdfunded a research facility in regenerative ag. That's never happened before. So if there's question of whether or not this is a valid approach to science and to agriculture, I think we're living proof that it is. I would not be here if it was just not for the tremendous team of young scientists from all over the world that have come to Blue Dasher to study and be a part of a movement. Oh, and one old guy right there, he's two old guys, I'm right there, I'll admit it. All right. Right, there you go. So if you want to know more about us, Ecdysis Foundation is our nonprofit. We are always needing more support. Ecdysis.bio, Blue Dasher Farm is right there. We're on Twitter, Facebook, and there's my email address. So I believe this is the future. Thank you guys all for listening, and lunch awaits.